All right, so we have this figure shows constant forces, F1 and F2, acting on a box as the box slides rightward across a frictionless floor. Force F1 is horizontal with a magnitude of 2 newtons, and force F2 is angled upward by 60 degrees to the floor and has a magnitude of 4 newtons. The speed V of the box at a certain instant oh goodness, is 3 meters per second. What is the power due to each force acting on the box at that instant, and what is the net power? Is the net power changing at that instant? So because we're given forces and we're given a velocity, we're going to use that power equation with velocity in it. So if we're trying to find the power due to each force, we just take them one at a time. So I have my power from force 1 will be equal to force 1 times velocity times the cosine of theta. Now here, remember, it is moving to the right, and force 1 is to the left. So we can see that this angle between force 1 and velocity, which is this theta right here, will be the angle between the force vector and the velocity vector in this case, is 180 degrees. So we get power from force 1 is equal to force 1, which is 2 newtons, times velocity, which is 3 meters per second, times cosine of 180 degrees. So we get 2 times 3, which is 6, times a negative 1, because cosine of 180 is negative 1. So we get power from force 1 is equal to a negative 6 watts. Now, same thing with force 2. Power from force 2 is equal to force 2 times velocity times the cosine of that angle. So here, power from force 2 is equal to force 2, which was 4 newtons, times velocity, 3 meters per second, times the cosine of 60 degrees, because 60 degrees is the angle between force 2 and velocity. So we get 4 times 3 times cosine of 60, and that ends up being a positive 6. So power from force 2 is positive 6 watts. Okay, so I have a negative 6 and a positive 6. And if I'm finding net power, because then it says the next thing is what is the net power, that will just be the power from force 1 plus the power from force 2, which of course a negative 6 plus a positive 6 is equal to 0. So our net power in this case is 0. Now the last question here, is the net power changing at that instant? Well, in order for the power to change, we have to have the work changing, or in this case, the force changing, or the velocity changing. Now, in this case, the force is not changing. Our forces are constant. We have 2 newtons to the left, and then we have that 4 newtons upwards at that 60-degree angle. And we can see here that because our velocity is not changing, our forces are not changing, also our kinetic energy is not changing, right? So therefore work is not changing. So here, because forces are not changing, kinetic energy is not changing, power is also not changing.